Okay, let's continue our journey in shell scripting. I will speak about conditions, if clauses, and then loops, for and while, and some other stuff. But let's start with conditions. Up to now, what I did was just writing simple commands from the shell in a file and call it with a shebang line and call it a script. Technically this is a script, but in many programs you will see conditions. If this happened, do that. Do this 10 times. Continue doing this while this condition is true. These kind of stuff. We will start with if. This is the general format of the if in a bash script. If condition comes inside the brackets, then do something. Else do something. Phi, which is very strange. If finishes with other side if, like phi. Okay? You can also omit this part and say if this condition is true, then do these things. Finish it here. If you are a programmer in other languages, you may find bash loops and conditions trivial, and writing them are difficult because it's very picky on how you write them. It needs some spaces on specific places. It needs this then, it needs the phi, but this is bash. They have tried to keep it small so it doesn't interpret different styles of writing, although you can have some of these in one line. This is a good example. What we had here, we had a small bash script which created a file with a date. But what happens if this is not provided? What happens if we just call it without any parameters? So my script without any parameter, it will create a file like this. It is ugly. I want to prevent this. So I will add an if condition here. I will say if this test is true, then do this. No, sorry. Let me write it. This is a specific variable which always contains the number of command line parameters. So I want to check if this is 1 or not. Tests are like this. Not equal to 1. I'm saying if spaces, please note the spaces, number of parameters not equal to 1, then echo I need exactly 1 parameter. Exit 1. I will talk about this later. Else, otherwise, do this. And exit 0, phi. I could write it in other styles too. For example, this exit 1 will exit from the script. So practically, I could just put my phi here and say if the number of parameters not equal to 1, right, I need exactly 1 parameter, and exit. Otherwise, it would continue the next commands. You didn't need this else and phi, but this is cleaner and nicer. You're welcome. This is how I write the conditions. Square bracket open, square bracket, and a condition here. For example, you can say if Linux equals Linux. Note the spaces. This is why when you are creating a variable, you should not use the spaces. So bash will know if you are checking something, if you are creating variables or assigning values to variables. Technically speaking, this is a shortcut of writing the conditions. The main method is saying test condition. But normally, instead of saying test condition, we write square bracket, condition, square bracket closed. This is nicer and easier and quicker than this. And conditions can be many different things like these. You can say A equals B, note the spaces. A not equal B. 4 is larger than 40, LT, larger than. So this is us. My apologies. Hope you are able to delete your memory. This is lower than, greater than, greater or equal, lower or equal, not equal. And there are also some other tests. For example, you can say test if the file exists, temp backup, do blah 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 blah. If the file exists. Else, if the file is not there, do blah 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 blah. For sure, you know that you need to use if test. Or you can do like this, which is easier. So you can say if -f, a file name, then blah 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 fee. Right? Easy. -f if file exists. -s if file exists and size is more than 0. -x if file exists and is executable. Something which we sometimes use is -e. If exists, it can be a file or a directory. So I repeat, lower than. Okay? So here I have if the number of the parameters to this script not equal 1, write echo I need exactly 1 parameter and exit with value 1. Otherwise, do whatever you were doing. This is super cool because we can say, I will save it. Here I can say script. It's called my script. I need exactly 1 parameter. Jadi is here. This has 3 parameters. So it says I need exactly 1 parameter. Say okay. Calm down. It will create this file with 1 parameter. It's nice. And also please see this. This specific variable always contains the returned value of the previous command. So this worked and I exited with 0. 0 is here. If I gave it the wrong number of parameters, it would return 1. Why is that? Because in this case, I'm exiting with 1. This is a method that many C programs use, and this is very, very widely used and respected in the C world. So, I mean the C programming language world. And from there, it came to the Unix. From there, it came to other programming languages. You remember, you used to define your functions like int, main, blah, 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 blah. And at the end, you would say return 0 when you were writing your programs in C. This return 0 can be read in this variable and used here. By convention, whenever you return 0, you are saying that program exited successfully. Anything other than 0 should be documented. So if our lovely program had a document, in document we would say return codes. 0, successful. 1, wrong number of parameters. 2, blah, blah, if we have something else here. So it's even very common to check the output of programs in your scripts and make sure that you are doing it correctly. As we see in the read example. Read something from the keyboard. I can say read name. It waits for an input. I say Jadi. Echo name. This is Jadi. I could say, okay, let's read from here. I have a sample here. It echoes what is your name, reads the name, says hello name, whatever you entered. If name equals Jadi, then echo, oh, I know you. Else, if it's not equal to Jadi, say, I wish I knew you. Fee closes this if and echo bye. You can guess how it works. A better example is this one, maybe a more realistic one. It says if read-t10-p blah blah server. So first let's describe this. Read, timeout is 10. Wait for 10 seconds and then timeout. And your prompt should be server address. Read the server. Let's try it. I can say read, timeout is 3 seconds, name. Jadi. Okay, it works. Echo the last output of the program, 0. It worked correctly. Read-t3 name. Timeout is 3 seconds. I waited for 3 seconds. No output. And you can see that the output was 142. This is not 0. So some kind of error happened. I can always check this to make sure that program is running correctly or not. Even if I did something else, Control C, break the program. So you can see that the lovely read program, which reads user input, if worked correctly, it returns 0. If timeout happens, it returns 142. If we break it, it returns 130. So non-zero values shows the problem. Here it is used directly. It says if, no conditions, this program. So if this worked correctly, read in 10 seconds the server address. If you were able to read it, say connecting to the servers, blah, 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 blah. Else, say too late. Interesting, not? Now you know how to make conditions. Let's go for the loops. In the beginning, we were just writing some lines in our script. Then we started using some logic. Now we go for loops. We have two different loops. For loops and while loops. For loops run one part of program or one part of your logic like this for specific number of times or on specific number of the objects. I will show you how it works, but the general idea is this. For variable in some list, semicolon, important, this one, I can do like this. Wow. Do blah, 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 done. So for variable in some list, semicolon, do, done. Let's try it here. I can say for v in 1, 2, 3, 5, 9. Then semicolon, do echo I'm seeing $v. Done. If you want to run this, there is no shebang, so I have to run it with bash and say, okay, bash, please read this file and run it. It says I am seeing 1. See what happens? For the first time, v is 1. So this program runs when v is 1. It says I am seeing 1. Then it is 2. Then it is 3, 5, 9. One by one, 4 goes through the list, puts the variable in this variable, and runs whatever is here. Okay, writing 1, 2, 3, 4, 5, 6, 7 is difficult. So there is one very famous command, which is sequence. Sequence 1 to 10. Let me show it here. Sequence 1 to 4. It shows 1, 2, 3, 4. If I want to use it here, I have to use the command substitutes. So at first I am running I'm running the sequence 1 to 10. It will produce 1, 2, 3, 4, 5, 6, 7, 10. Then I will have this loop. So the first time this thing being run, v will be 1. Second time it will be 2 till 10, and then it will finish. So I can say this, and I'm saying 1, 2, 3, 4. Sequence do have some features. For example, you can say 1, but I have the steps of 3. I want to reach 10. It says, okay, 1, 4, 7, 10. You could have 4. 1, 5, 9. 1 till 10. Steps are 4 at a time. This is another method of using for. For sure, you could also do the other commands here. For example, it's very common to do a ls. ls will return all the files here. For example, f1, f2, script, and my script. The first time the loop runs, v will be equal to f1. The second time it will be equal to f2. Then this one, and then this one. So if you want to run something on all your files in a directory, you create a script, run a for loop like this. Says all the files, I'm seeing my script, I'm seeing a script, I'm seeing this, I'm seeing that. Isn't it cool? This is how for loops. And this is the shortcut for the sequence. You can write it like this to make it much faster. And another loop is while. As you saw, for loops were running on a specific list. Whiles run based on the condition. You say, while this condition is true, do these things. One example is here. I say var equals 52 while var is greater than 42, do these things. Echo var is $var and it is still greater than 42. Cool. Let var equals var minus 1. This let is another command you should know about. It lets you do arithmetic calculations. If you have a variable, you can say let v equals v plus 5, 4. Echo $v. So it's 12. Please note, I didn't use dollar here because let knows that these are variables. It lets you do arithmetic calculations on your variables. So here I have a loop. The first one, var is 55, so var is greater than 42, so this continues. It prints var is 52 and it's still greater than this. Then let var equals var minus 1, so it will become 51. Again, it is larger than this runs. Then it becomes 50, 49, till it becomes 42. And then when checking while 42 is greater than 42, no, so it will continue from here. This is how loops work. Very useful sometimes when you want to continue your program while a logic is there. Again, remember, you don't need to write complicated scripts on LPIC 1. And maybe in real life, I myself prefer to write my programs in Python and code. Depends on what I want to do, to be honest. Next section is a little bit strange, sending mails to the root users, but the point is sending mails is complicated in general. I think on LPIC 2 it's a complete section, sending mails. At least one part of it. But we have a mail command. I can say mail. It is not installed most of the times. You need the mail utils package to use it. But when installed, it's very easy. You say mail to the root user on this system. You can even do mail jadijadi@gmail.com and send there. I'm not sure if Gmail accepts this or not because it may think that you are spamming and send it to the spam. But technically you can do this and sometimes it works. I use it a lot because I add my address and I have my domain. Anyway, but you can say mail root, then it will ask for your, if you have any carbon copies to other people, then it will ask your subject, then you write the body, and I think Control Z will finish your line on the new line. And as soon as root logs in and runs the mail, he or she can read the emails. So it's very common to send it in one line. Echo body of the email, pipe it to the mail with this subject to the root users. And in one line, you are sending an email to the root users or whatever user you want with this subject and with this body. So in the script, it's very common to do something. If it is good, finish it. If not, mail the user that this is happening. Or as I told you on the previous section, you can say, run this script or do this, or mail the root users that I had a problem. So if this is true, if you return 0 and this is true, this won't run. Otherwise, this will run and the root users will know what is going on. And return values I already talked about. Cool. As a bonus, I've uploaded a very, very simple backup solution I use whenever I want to quickly back up some server with a Chrome tab. You will see this later on the next chapters. And so you have something to look into. I will try to add a couple of more cool scripts here so you can study them and understand how other people write their scripts. Have fun.